Hey, what we're going to look at in this lesson is when a limit does not exist. And just a real quick background information on that. You are going to have a limit if and only if you approach the same y value from both sides of an equation, on an equation from both sides of the point you're interested in. So if we're talking about limits, we're going to have limit notation. So we're talking about the limit as x approaches whatever it might be, some x value of a function. And what this is going to be the y value that we get close to. Okay? So I've got some examples here that we're going to talk about today that deal with limits that don't exist at specific places. This first one, we've got the equation y equals absolute value of x divided by x plus 3. And you'll notice that anytime the x value is 0, we're going to have an issue. So x cannot be 0. So in order to investigate this a little further, let's just go for broke here. What if we looked at the limit as x approaches 0 of absolute value x over x? So what if we checked this guy out? Okay, and what does it equal? Well, to do that, we need to look at what the y value we're approaching from the left side is and what the y value that we're approaching from the right side is. And as long as those two y values are exactly the same number, then we have a limit. So I'm just going to toss in like a 1, say, here. I'm going to put a 1 in. That'll give us this value right here. So if x is 1, and notice we've got a straight line. So if we put 1 in, that'll tell us what our y value is, and it's not going to change. So if we look at f of 1, I'm going to have the absolute value of 1 divided by 1 plus 3, and that's going to give me a y value of 4. So what we would say is the limit as x approaches 0 from the right of this function is 4. Okay, investigate further. What if we looked at this point right here, -1? So the function then at -1, what is it going to look like? It's going to look like the absolute value of -1 divided by -1 plus 3. Well, absolute value is always positive because it's a distance, and a positive number divided by a negative number is negative. So we actually have here -1 plus 3, and that's a 2. And so the limit as x approaches 0 from the left of the function is 2. Well, if you'll notice, these two limits right here, these two limits are not the same. If they were to equal each other, then we would have a limit at 0, but they don't equal each other. So at this point, we would say that this limit then does not exist. And basically what you're thinking of, visually, if you are lining up your fingers to touch, then you would have a limit in that space in between your fingers. Whether your fingers actually touched or not, you'd have a limit. But if you're trying to touch your fingers and they're lined up in different spaces, you're not going to touch them. And if they can't touch, the limit does not exist. So if you trace this graph with your hands, you'll see that there is no limit at 0. Okay? Let's check out a different one. It looks a little different. How about this guy? Y equals x minus 5 over x squared plus x minus 6. Let's take a look at this and see what happens. So what we're going to look for is, let me get a darker color here. We want to look at the limit, and we can take our pick here in a couple different places. I'm going to say it looks like something is going on right here. There's also an issue with an asymptote right here. So this would be the places that we really want to investigate, are these two asymptotes. And to figure those out, just real quick sidebar, let's go ahead and factor the bottom out. So we're going to have an asymptote at -3 and an asymptote at 2. Okay, So let's check out the limit as x approaches 2 of this function x minus 5 divided by x squared plus x minus 6. Now, if we go with the whole, they've got to line up and touch. Well, if you trace out the left-hand side of this graph as we get close to 2, and you trace out the right-hand side of this graph as we get close to 2, then your fingers and hands, they're going in different directions. So our first guess here is that this limit does not exist. So what we can do is we can check points as we get really, really close to 2. We can look at the limit as x approaches 2 from the left, and we can look at the limit as x approaches 2 from the right. And in order to actually have a limit at this specific point, then I have to have the same value for the green limit and the blue limit. Okay. Well, as we come into -2 from the left, and you might want to use your calculator on this just to double check me, but as we come into -2 on the left, my y values start increasing the closer we get to 2, and they keep increasing and keep increasing and keep increasing, where we would say that as we come in from the left, that limit goes towards positive infinity. Okay, that's not really a limit at all. Remember, infinity is more an idea than anything else. As you come in from the right, let me get a color that will show here. As you come in from the right, you'll notice that our y values are getting smaller and smaller and smaller. And in this case, our limit is going to negative infinity. Well, negative infinity is also more idea. It's not really a limit at all. And so now what happens is when we look at this point where x is approaching 2, so we're approaching from this direction and we're approaching from this direction, notice that we don't line up. We don't approach a specific point. So it's safe for us to say, in this case, that our limit does not exist. So we can get rid of that question mark because now we have a true statement. Okay, that's a little bit of how limits work and what's going on with them. And so I hope this helps, seeing some different places where limits do and don't exist.